At E12, I'm about to go through the first set of revision questions, differentiation. So I'm just about to share my screen. This is the Word document that you've been emailed. I will send out a different version that's got all the solutions in. So let's go back to the start and do the differentiation. So let's put a few gaps in. So you'll recall that with differentiation, it's essentially writing everything as a power of x. So you'll get some questions that have got square roots in and fractions. We have to write those as a power of x so that then we can reduce the power by 1 and multiply by the whole power. So with this one here, we have got dy dx. So I would write the half down and then I think about differentiating x to the power of 4. Differentiate x to the power of 4 for x cubed. Differentiate 3x. Of course, think of that as x to the power of 1, reduce the power x to the power of 0, it vanishes. Whenever you differentiate anything multiplied by x, the x always just vanishes. And then just tidy that up. 2x cubed minus 3. Second one here, we cannot differentiate it as it stands. So please, please, please don't be differentiating this, and then multiplying the two answers. We're not able to do that. What you have to do first is expand the brackets. So if we expand the brackets, we get 2x cubed plus 2x squared plus 3x plus 3. I'm not sure why that's gone to a fat pen. Let's change colour. Actually, there's nothing there to simplify, so we can just get straight on to the differentiating. 2 multiplied by differentiate x cubed, 3x squared. And then I've got 2 multiplied by differentiate the x squared, 2x. Differentiate 3x, and we just get 3. Differentiate any constant, of course, we're going to get 0. And then tidy that up, 6x squared plus 4x plus 3. Now, this next one, we have to rewrite it in a form that doesn't have that square root there. So rewriting that, you know, a square root is a power of a half, a cube root is a power of a third, a fifth root is a power of the fifth. And as soon as you've got that, we can now do the differentiation. So power, bring the power down, write your x, reduce the power by 1. So you've just got to be a little bit careful here about negative numbers. If I'm subtracting 1 from a fifth, I'm going to get negative 4 fifths. And exam mark schemes would probably, well, would give you your marks for that, but I know some of you might like to rewrite that without that negative power. That is the same as 1 over 5, so because it's a fifth, that 5 would be on the denominator, and then x to the power of 4 fifths. That negative power would be a positive power when it's on the denominator. And the last one of this section, I need a bit more space. We have to differentiate this, so it's not as explicit in the previous questions that say differentiate, but you know that whenever it's talking about the gradient of a curve, that is differentiating. So the gradient of the curve, we need to find dy dx. Before we can define dy dx, we need to rewrite that. So y equals, now they've been a bit sneaky here. That square root, of course, is just for the 2. Okay, so you don't need to do anything about changing that x, that power of x squared, just x squared. However, this next one here, the square root is on the x, so I do need to change that one and write that as x to the power of a half. And again there, the 4 root 2, it looks really horrible, but that is just a number. This here, the x is greater than 0. Don't need to worry about that as part of the equation. That is just making sure that we don't have any worries about this term in particular. That term being negative. If that term is negative, we can't square it to negative, and then the function will be undefined. So that's just a little qualifier just to say that everything with the function is okay. So we can just go ahead. So if I differentiate that dy dx, this root 2, just write it down, and then as you would do with any other number, just differentiate x squared. X squared differentiated is 2x. Here I'm going to write the 6 down, and then I'm going to think about differentiating the x to the power of a half. I will bring the power down a half x and then reduce the power by 1. So minus a half. And then this here, that of course is just a number. If you just had plus 4 on the end, differentiate that 0. 4 root 2, differentiate that, we get 0. So then I just need to tidy this up. The 2 times by root 2, well, I'll just write it as 2 root 2 x, and then I have to multiply 6 by half, so that's going to be negative 3 x to the power of negative a half. And we can leave it like that, or 2 root 2x minus 3 over root x. So the 3 there doesn't have any power attached, so that has to stay on the numerator. However, the x has got negative power, so that absolutely will go on the denominator. And go back to the question, what we've actually got to do, find the gradient of the curve. So what we've got here, this expression is the gradient function. So what I've got here, my dy dx, I'll just write it again on the next page, but I don't want dy dx 2 root 2 x minus 3 over root x. That tells me the gradient at every point on the curve, the gradient function. We need to specifically work out the gradient when x is 2. So the gradient when x is 2, we are just going to substitute 2 into that previous line. So it's 2 root 2 times by 2 minus 3 over root 2. We end up with 2 root 2 times by 2, that's 4 root 2 minus 3 over root 2. And if we look at what the question asked, the question wanted us to write it in the form a root 2. Okay, what I've got here is 2 different terms, but with that second term, we can rationalize the denominator. And by doing that, I end up with 4 root 2 minus, multiply the numerators, 3 times by root 2 is going to be 3 root 2. On the denominator, I've got root 2 times root 2, which is just 2. And again, it looks a little bit odd, but if I think of it as 4 root 2 minus 3 over 2 root 2, I can then work out 4 minus 3. 4 minus 3, 4 minus 1.5 is 2.5, or 5 over 2 root 2. Just check again how it wanted me to write the answer. Yeah, write your answer in the form a root 2, where a is a constant. Yeah, so a would be 5 over 2. So there's my answer. Okay, so that's your basic differentiation. Let's move on now to the first of many different applications. So tangents and normals, finding stationary points, and also increasing, decreasing functions. But let's certainly get this section done on this first video. So find the equation of the tangent to the curve when x equals 2. So the curve itself has vanished. Where is it? Up here. So we've got why can't I get my pen back? Okay, so this video is stopping here, and I will do the next section on the next video. Apologies. Let's stop that. Stop presenting. Stop.